yesterday, or maybe the day before yesterday, you you did the contest. Yesterday. And most of you solve at least one problem, right? Okay, good. Okay. And Alhamdulillah, I'm fine too. Thank you for asking. And then let's begin our lesson with praying. Rabbana zidna ilma warzuqna fahma. Amin. Okay, let me share my screen. All right. So, mm, yes. Again, Abdullah got the highest score, and then Ahmed. Wait, then the others got 100. Okay. Did you get more points than here? Oh, okay. So this is your score. And then is there any specific question about a specific problem? Okay. I think last week we discussed the fourth contest, the NOI one. All right. There is a question from Ahmed. How about problem B? In fifth contest or sixth contest? All right, sixth. Okay. This one, if I not fault, the solution is using Centroid. So let me ask Abdullah. Uh, you could accept it, right? So please explain your solution. Okay, good. Then explain more. But from the room to the Centroid. Okay. I think the safe, right? The path from safe room to the Centroid. Okay. There is a safe node and then there is a Centroid. Okay, then okay. Okay, we can mark pass with 1 and then the other is just 0 or vice versa. All right. Okay. So yes, whenever we are in a room with zero, we can always hit centroid. Okay, because centroid is unique, or we can easily know the centroid without knowing without knowing the label, without knowing any information. We just need the graph, right? If we know the graph, we can find where is the centroid. So even in locate function, we we are given the graph, so we can easily know the centroid, right? We can easily know the centroid. Okay, so we can just go to the centroid. Okay, yes, there is another limitation. Okay, we cannot move more than t plus 30. Okay. Okay, so let me ask Abdullah how to make sure the number of moves is t plus 30. T is the distance between the current node to the safe. Only two child, but actually the path can be so long. For example, okay, before that, we need to notice this constraint. Each room has at most three doors, and there is a case that the graph is line graph, right? And of course, the centroid is in the middle. But wait, okay, I think not a line graph, but a caterpillar. Do you know what caterpillar looks like? Okay, this is caterpillar graph. This just like this, right? Caterpillar. Okay. And there is another constraint. The maximum n is 45,000. What does it means? We can make the distance here is 10,000, right? So the the number of nodes is only 48,000. Okay. Okay, Abdullah, explain like this. Is a visited array, okay. Let me read your chat. Okay. Okay, that's it. Mutahir is correct. Okay. The problem is in implementation. I think the implementation is not too hard. It is relatively simple. So who solve this problem? Okay, only Abdullah. Okay, Abdullah answering. We'll do that. Highest subtree size, but the size is less than half. Wait, let me check. Highest subtree size and less than half. Do you mean like this? For example, we are in the centroid and it has three edges, but one of them is parent. I mean the previous node we visit. Then we move to this and finally the value is 1. It means it is in the path. Then we will guess whether we should go to the left or go to the right. Wait, what is n? N is the number of nodes in the tree or just in the subtree. Tree or subtree. Okay. Go to the child has the highest subtree. lesser than n plus 1 divided by 2. Okay. All right. Okay, I think. Wait, let me ask again to Abdullah. What is n? N is number of nodes in the graph or in subtree only. Okay, the number of nodes in graph, right? In graph or in subtree only? Okay. Okay, in Mark you use DFS, you look at DFS and DFS2. DFS2. Alright, what is DFS? Finding the size and okay, checking where is the path to the centroid. And then for TFS2, if it is 1, it means it is okay. 1 means outside, right? Outside the path. Okay, yes. So 0 means inside the path, 1 outside the path. And then wait. Okay. So we can easily find, you can easily go to the centroid, right? But if t is 0, then for example, this is the parent, and this is the current, and it has 2 child. Okay, I see. At first, we try to choose the largest one. Okay, we are avoiding this just in case like this, right? There is a path from centroid to safe. when we go here, we will avoid go here, right? So we want to make sure that we we avoid centroid, right? We don't want to go to centroid. Okay, I see. Okay, let's say current is the root. We start from the root, and this is the centroid. And then when we go inside the path, we will avoid this, right? We don't want to go this. So we have to make sure that we will go to another direction, right? Okay, we will go to another direction. And then do you always okay, so you always choose the highest, right? So if there are two options, then just like what Mutahir said that we will choose the maximum size, right? Between these two options. For example, the maximum is this one, then try to go here. Why? Because if it is correct, then okay, we uh, we don't need any additional cost or additional move because it is correct, so it is still inside, still in T. But if it is incorrect, okay, and then we lose two moves, right? Because we need to go to the wrong path and then we need to go back, right? Okay. Wait. You should pass through at most 3 plus detours. Alright, yes. So actually we lose 2 moves, right? But don't worry, when we lose 2 moves, then the size of this is at most half, right? So it is just like divide by 2. So the number of wrong moves is at most log n, right? Only log n. Okay, that's it. Yes, actually 2 log n. Okay, is it understood? Okay. Yes, the solution is like this. At first, okay, let me summarize the solution. At first, we will mark the path from the centroid to the safe node. And what if the number of centroid is more than 1? The number of centroid is at least 1, right? But sometimes it is more than one. So what should we do? Do you know what is the maximum number of centroids? 2, that's it. Okay. The maximum number of centroid is at most 2. Okay, then for example this is the safe node and this the centroid 1, centroid 2. Then let's mark them as 0, right? Or as 1. And the others just 0. Okay. So when we go to this to any centroid, then finally we arrive at 1. Okay, then what if one of them is centroid? Sorry, one of them is safe. Wait. Or maybe just mark the centroid that closer to the safe. Okay, I think like that to differentiate when the centroid is at this, the safe is at the centroid, right? So when we arrive here, just move to another centroid and finally got 1. And then just continue moving like that. And finally, if we arrive at the safe, we go to the child and there is no other 1. So it means this is the last, right? This is the last 1. So it must be the safe. All right. Any question? Okay. Okay, there is another question from someone. Why it is lock n? Why to lock? Because if we move to the wrong path, wrong direction, and we need to go back, it means the size of this is more than the other one, the correct one, right? So A is greater than or equal to B. What does it means? If A is greater than or equal to B, while let's say this is C is equal to A plus B plus 1. So the number of possibilities, I mean, when we arrive at C, actually there are many possibilities for safe. The safe can be anywhere in the subtree. Then if the correct path is here, so the possibilities for the safe is in the subtree, right? Yes, that's it. The sorting space is reduced. Okay, because A greater than or equal to B, and we know that C is equal to A plus B plus 1. So it means B is less than C divided by 2. Okay. So since it is divided by 2, then just continue divide by 2. And of course, if we divide c by 2 log n times, then it become 1, right? At some point it become 1. So there is only one possibilities for safe. So it must be the safe. So the number of incorrect moves is at most 2 log n, right? Okay. So what if n is up to 45,000? 45,000. So for example, we arrive at the centroid. Okay, there is another question. If there are two centroid and one of them is safe, okay, then we only mark one centroid, right? We only mark this and the other node is just 0. So when we move from the root to this centroid, just go again to this centroid and finally we get 1, right? And we try to move to its children, and unfortunately it is 0, and go to another children and it is also 0. So it means this is the safe, right? Because both children have 0 value, right? Okay. What else? Okay, no problem. Then what is the exact complexity? Okay. N is up to 45,000. So when we arrive at the centroid, it means the possibilities here is at most like this, right? And if we are wrong, then the next possibilities is okay, actually still okay, less than this. And then if we wrong again, then it is less than this, right? So what is 2 power 15? Okay, it is more than 2200, right? So it is enough. Okay. All right. No question. And then how about the previous contest? Any problem we need to discuss? I think in the last meeting, Hassan asked for problem B, right? So do you know the solution for now? Actually, most of you solved this, so can you explain briefly how to solve this? Okay, not remember. Okay, sorting to remove absolute. Yes, that's it. So we will uh, sort based on what? Sort from X or based on E? Which one? X, okay. So now there is no absolute. What is next? Okay, yes. Now, for example, we assume J is less than I and X is sorted now. So we can easily use this inequality, right? What's next? We can move this, right? Yes, we can change the inequality into like this. And then, okay, for a fixed I, can we find possible J? Okay, so we can easily find the running maximum, right? Running maximum for this value. And then if this value is less than or equal to that running maximum, it means okay, I can get from that, right? Is it correct? Okay, wait. I think if I want to get from another one, it should be like this. AJ minus AI. What do you think? Which one is correct? Or actually, there is an observation like this. You know, there will be no cycle if from some node can go to, can copy to another node, then there is no cycle, except when both X and E are same, right? If both of them are same, then okay, of course, it will be full graph, right? It will be complete graph. But actually, we can easily remove them, and just assume it is only one node. So we will remove duplicates, right? If we remove duplicate, it means there will be no cycle. Why? because we can only copy from one node to another if the previous A is greater than the next A, right? If it is smaller, then it is impossible. Why? Because, wait, yes, because if AI is smaller than AJ, it is negative, right? If it is negative, and absolute value always non-negative. So of course non-negative will be greater than negative. So it is impossible. Then it should be greater than or equal, right? So there are two cases. The case when it is greater than or the case when it is equal. If greater than, okay, it is possible. But if it is equal, you know, if EI is equal to EJ, then EI minus EJ is equal to 0, right? So the only option is when XI minus XJ is also 0. And we already removed duplicates, right? So there is no such pair. So this pair is not exist since we remove duplicates, right? Okay. So if the edge is always moves from higher E to the smaller E, so it means there is no cycle, right? So the graph is directed acyclic graph, right? Check. The graph is check. And then we just need to count the number of nodes that doesn't have any in degree, right? For some nodes that have an has an in degree, it means no need to donate to this node because it can buy from another node. But for a node that there is no in degree, so we need to donate here. So it means we just need to count the number of nodes that doesn't have any in degree. Okay, you got it? And then let's continue to the sorted array. For example, we want to check whether I has an in degree or not. So we will check whether I has an in degree from left or I has in degree from right. And then, if either of left or right exists, so it means no need to tune it on I. Otherwise, if neither is exist, so we need to tune it at at I. So just answer plus plus, right? Okay. Then how to check that? At first, you want to check from the left. It means if I can get from some other node, it means the distance should be less than or equal to ej minus ei, right? So we can easily move them. And finally, we just need to use running maximum. Do you know what is running maximum? Just like prefix maximum, but no need to store the array. Just one variable. Do you know what I mean? I mean, it is just like iterating from 1 to n while storing the max. Max is equal to max between max and xi plus ei. Okay, this is called running maximum. So if xi plus ei greater than max, it means it has not any left in degree, right? But if it is less than or equal, then it has. Right. And then use the same idea from the right, so we can easily know for each node whether it has integrity or not. Okay, no question, right? Maybe let's move to the problem. Okay, Abdullah got accepted on this problem. Wait, I think not this problem, but this one, right? So anyone absolve absolve this problem? No one. Okay, then maybe Abdullah, please explain your solution, how to solve this. Okay, persistent segment tree. Okay, good. Okay. So how you create persistent segment tree? Okay, so what is the definition of your persistent segment tree? Okay. Okay. So yes, the idea is like this. For example, given a query from A to B. So we need a binary search, right? Did you use binary search? Is there any binary search here? Okay, in LCA. No binary search. Okay, for example, is LCA. And we have some golds and some silvers. We can take maximum node using silvers, right? We can take minimum, I mean, cheapest nodes such that the sum is still less than or equal to S. And then the rest is use gold, right? So we can easily know how many number of code needed. And then if the number of code is less than or equal to G, okay, then output G minus code needed. Otherwise, output -1, right? Or just do this max between -1 and G minus needed. Alright. Okay, is it understood? So where is the hardest part? The hardest part is on the silvers, right? How to know the maximum number of nodes such that the sum of the cost is less than or equal to S. This is the hardest part. After we cut this, we can easily use this formula, right? And actually needed is equal to distance minus the number of silvers, right? And distance is depth of A plus depth of B minus 2 times depth of L, right? Yes, it is easy. Okay. And then how to find the maximum node we can get using silvers? At first, wait. Okay, yes. At first, we need to sort the cost. The cost is like this. Sorry. We need to sort this. So, of course, we prefer the cheaper one, right? Than the more expensive one. So, we sort this. And then, okay, we will create a sparse table for LCA, right? For binary lifting. Okay. And while we do DFS, wait. Okay, so we have a persistent segment tree, right? Persistent segment tree for each nodes is like this, right? For example, the parent has a segment tree, and the child is just like the parent. The segment tree are same, but we will update like this, right? We will add column I. Okay, yes. If this is, if there is a cost here, the cost is something, so just activate. So initially all of them are 0, so just activate. Then we can easily know the total cost from the root to that node, right? We have the segment tree knowing which cost we need to pay, right? And we can simply binary search on this. Actually, not binary search, it's only just like binary search on segment tree. So the complexity is still log n, not log square n. Okay, that is what I mean with binary search. Okay, so if we know this segment tree for its nodes, so when we know the LCA, we can easily know the combined segment tree, right? The combined segment tree is segment tree A plus segment tree B minus segment tree L, right? I mean minus 2 segment tree L. So just binary search on that until, okay, just binary search on the maximum index such that the total cost is still less than or equal to the silver. And then after that, just count how many number, wait, okay, how many number of gold needed to pay for the others, right? Just count the number of gold here. If we cut the number of gold, then we can easily use this formula. Maximum between -1 and gold minus this. Okay, is it understood? So let me ask Abdullah, what is the complexity for this solution? Log square. Wait, in the pre-computation, this is only n log n. This is also How about creating the persistent segment tree? There are n updates. Each update is log n only, right? So the time complexity is n log n, and the memory is also n log n. What else? So that for each query, we need to find the LCA, right? To find the LCA is log n, right? And then after finding the LCA, we also need to query like this. Is it just log n? Actually, we can solve it in log n only without log square. But if you use binary search and query on segment trees separately, then yes, it is log square n. But actually, you can solve it together. You can do it together, so the complexity is log n only. And I think you did that. The complexity for this is log n only, not log square. Okay. So yes, the total complexity is only n log n. There is no square. Actually, this trick called walk on segment tree. Walk on segment tree is combination between binary search and query on segment tree. If you use this, then the complexity is n log square n. But if you use this, it is only log n. Do you know this trick? Anyone knows? Or should I explain to you what is walk on segment tree? Okay, you know it. So basically, if you use binary search plus query on segment tree. Okay, yes, that's correct. Actually, if you use conventional way, it is just like doing binary search, right? And then try to query on segment 3, right? For example, if query on segment 3 A from 1 to mid, okay, plus query on segment 3 B from 1 to mid minus 2 times query on LCA from 1 to mid. If it is less than the number of silvers, then just go ahead or something like that. And then the complexity is log square n. Why? Because here we need log n for binary search and another log n for querying the segment tree. But if you use this, then it is only log n, because it is like this. So we will check the left child like this. So from the root of this segment tree, we will check the left. If it is less than or equal to the query, then move to the right. But if it is less than, then move to the left, and so on. Okay. Until arrive at the leaf. So it finished. All right. Okay. Any question about the solution for this problem? Okay. I think it is enough. So maybe let's find another interesting problem. Actually, I have another interesting problem. There are many solutions to solve this. Okay, let me share the link. Okay, let's read this problem. Okay. If you finish. Okay. Any idea or observation? Okay. Okay. Yes, Zishan got an observation. So yes, if there is a group of, I mean, province, then the cost of that province is the number of cities, just like the size minus 1 times total A. Is it correct? Yes, we need to create a complete graph, right? So the degree of a node is size minus 1. And the cost of this, it means A need to pay AI and J need to pay AJ. So each node need to pay A times the degree, right? And the degree is equal to size minus 1. Okay, good. Gomez got another observation, but I don't think so. Most expensive. Okay. Actually, not always. Sometimes they are in the same province. For example, like this. One province is 1 to 5 and the second province is 3 and 4. You know, the first expen the first most expensive and the second most expensive is in one province, in the same province, not in different province, right? So it means your hypothesis is incorrect. Okay. You should think about greedy solution. So how to use greedy? No, this is the index, not the cost. This is the index. So island 3 and island 4, the cost is 5 and 4. And they are the most expensive. Okay. Let's think about binary search. Yes, maybe there is a solution using binary search. Actually, I know at least 4 solution. At least 4 solution, maybe more than that. And the complexity are same and square log n. But so many variation of solution. Yeah. Okay. Ahmed, think about TP. Okay. Yes. We can use TP. We can use TP with 2 states. But actually, before that, so is I the index of the city? If I the index of the city, please notice that the province is not always consists of continuous nodes. I mean continuous cities. For example, like this, 1, 2, 5. It is not continuous, right? And it is possible or allowed. Okay. So it is not always separate. Okay. Session, think about sorting the elements. That's it. We can easily sort the element. What for? Why we sort the elements? Yes, we can sort the element and run TP. Why? Because if we sort the element, then the optimal way is always, I mean, making a province consists of a subarray. right? Do you know why? Yes, how to prove it is the most optimal. Actually, the proof is like this. Let's begin from Zishan's observation that the cost of each province is size minus 1. Actually, Zishan said like this. The contribution cost for each node is AI multiply the number of the city, the number of cities in his group or in its group minus 1, right? Okay. Yes. Yes. Mutahir said that. Okay. Yes, Mutahir is correct. So the idea is like this. For example, the size is fixed. We already fixed the size. For example, there are 10 cities and we already fixed the first province consists of two cities and the second is consists of 4. The next consists of 2 again, for example, and 4 again. Okay, maybe let me make it like this. 2, 4, 3, 1. Okay, so it means all cities here, the contribution is multiplied by 1, and here multiplied by 3, and here multiplied by 2, and here multiplied by 0. So to get the optimal cost, how to get the optimal cost? How to put the cities into groups? Just like what Mutahir said. The smaller value, yes, yes, Ahmad is correct as well. The smallest A will be inside the biggest components, right? And then the next smallest inside the next biggest, and so on. Okay, it is easy to prove, right? This is the optimal one because we want to minimize. So the most expensive will contribute the least, and the cheapest will contribute the most to achieve the minimum cost, right? Okay. Finally, if we know like this, this is just like creating some subarrays, right? Some segments. This is the first cheapest cities, and then this is the next cheapest cities, and so on. That's why if we sort from the cheapest to the most expensive, so we can make sure it is optimal to divide into subarrays. Okay, so that's why Gama's previous idea is incorrect, because Gama said that the K most expensive should be in the different group, but in fact it is not. The truth is some most expensive will join into the the same provinces, the same province with with the small size, right? Okay. All right. So let's recall the TP proposed by Ahmad. The TP is two states. This is the index and this is the number of province. And we want to minimize like this. Is it correct? The transition is checking every index, right? Okay, so what is the complexity? Okay, naively it is on to the power of 3. So how to reduce it? We can reduce it, but how? Rather than increase I, we can increase J. J outer loop. Okay, I've got an idea. What if J is in the outer loop? So what is the transition? You need to iterate back. Okay, wait. Let me let me type the formula. We want to minimize this plus like this. Is it correct? Okay, maybe Ahmed, can you drop your idea here? What is the formula for that array? How to optimize this? So is this formula correct? Or do you have any other formula? Okay, it's just if we do it naively, we will do this, right? This is the naive solution. Okay. Then how to optimize it? Okay. What do you think? Let me ask Abdullah. So, do you have any other formula, or do you agree with this formula? Is this correct? How do you think? Hmm. Okay, I think the previous idea proposed by Ahmad is hard to solve this because the formula is like this. Actually, there are some trick to optimize this. One of them is the easiest one is using harmonic series. The second one is using TP divide and conquer if you know it. The third one is using binary search, or we call it Mongi. Some people call it Mongi. Mhm. The other one is using Itao tree because there are many ways to solve this. Okay, let's discuss the easiest one. The easiest one is using harmonic series. Do you know what is harmonic series? Okay, like this. So how to apply it to this solution? Okay, actually we have an observation that the size of the subarray always increase or decrease? How do you think? The size of subarray is increase or decrease? Okay, wait, Ahmed got some formula. Let me check. Let's say we have an array of tests. This means the cost, right? The cost is like this. Okay. Let's say the cost is just like this. Ref R minus ref L minus 1 multiplied by R minus L. Okay, wait. Okay. Should we change dpij if it is less than? So what is your intuition? How you came up with this idea? Maybe you can try to implement it and try to submit it. Okay. But the other idea, we can use harmonic series because you know, okay, we must say that the subarray is decreased. Okay, or more precisely, it is not increased. So it will be smaller than or equal, right? Okay. So what does it mean? So it means in the last group, the maximum size is n divided by k. Is it correct? Okay. Because if the size is greater than n divided by k, then everything is more than that, then the sum is greater than n, and it is impossible. And then for this, the size is at most n divided by k minus 1. Is it correct? And then for this, it is at most n divided by k minus 2 and so on. And this is at most n, right? You got it? Okay. So basically, we don't need to check all k. We just need to check from I minus what? Minus n divided by j, right? Max with 0. So we can change it into like this. Do you agree with me? Because the maximum size is at most n divided by j. Floor. Floor or sail? Floor, right? Okay. So what is the complexity? You know, when j is equal to 1, then the complexity is n squared, right? After that, when j is equal to 2, what is the complexity for this iteration? N squared divided by 2, right? Because it is On and this is n divided by 2. And then for j equal to 3, it is n squared divided by 3, and so on until n squared divided by k. Is it correct? Okay. So what is this? You know, there is a harmonic series. You know, 1 divided by 1 per 1 plus 1 per 2, 1 per 3 until 1 per k. It is log k, right? Okay. And then we multiply by n squared in each term. So it is n squared log k. Okay. All right. So this is the complexity. So it will pass the time limit, right? Okay. Any question? No question. Okay. So for harmonic series, it is n square log k. For divide and conquer, it is kn log n. For Monge, it is n square log infinite actually. I mean log a times n. Wait, or let's say log 10 to the 18. For Litsao 3, maybe n square log n. Or maybe kn log n. Okay. There are so many ways, but at least you know this solution. This is the easiest one. But there is another option, for example, using DNC. So we just need to do DNC like this. And the complexity is n square log as well. We can also use binary search, just like what Hassan said. Just binary search, NDP. We can also solve using this trick. And I think on contest, some people use different topics. Just like Litsao 3, for example. Yes, I think he used Litsao 3, right? And it is the most complicated solution, I think, for this problem. And for this, it is using Monge binary search. And some of them using DNC. Okay, this is DNC, I think. Wait. Okay, no. This is using Monge binary search. Okay, I think this one using disjoint set union. Okay, maybe there is another alternative. Disjoint set union. Okay, interesting. Okay, I think you can try to upsolve this. And that's all for today. Thank you very much for the lesson. And see you again next week, inshallah. Okay. Thank you very much. Let's close our meeting with praying. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Allah Hafiz.